Looking at the sun in 171 angstroms, we got very, very low activity. As active regions and coronal holes rotate to the west, there's not a lot to look at. A low solar wind. Here's your magnetic lines. It looks like a coronal hole down here, but the phi angle does not support this theory. Check out 304 angstroms. Pretty serious filament activity going on the southeastern limb as well as the northwestern limb. No sunspots. Those active regions have weakened, and there are no umbra. There are no umbrae. Let's look at some other data before we really get into the weeds here. Head to spaceweathernews.com. So, X-ray flux is absolutely flatlined. Nothing above the A range. And no significant fluctuations. Now we can see the phi angle is up around 300, which is associated with that northern coronal hole. And we have forecasters predicting a coronal hole wind stream today, possibly setting off a G-class geomagnetic storm. So we'll be keeping an eye on that. But for now, very low activity. 316 or so kilometers per second for the wind speed. And the wind density under 10, at least. Magnetometer's looking pretty smooth and pretty weak. But the main data is that KP index. We've had about 2 days here with the KP of 0 and 1. And so, all things considered, that should be a cosmic ray warning. We're going to cover it. We're going to get deep into the weeds. There's your F2 ionosphere map. Looking pretty normal. And the aurora borealis and australis are looking a little bit more charged than we expected. Check out the earthquake situation. Head to global incident map. Got some deep quakes. Check the last 8 hours. So we got a 4.7 at blot echo depth in Chile. Now let's see, have we had any around the 5 range? New Zealand got a 5. So Chile got a 4.5. Indonesia had a 5.4. Could be expecting more earthquakes in South America. Not so sure on that one, just wanted to give you an update. As we're hanging around in a grand solar minimum, let's see what's going on at Tropical Tidbits. Well, I'll tell you what's going on. Half of the country is having a massive temperature anomaly. You're looking at, what is that, about 12 degrees below normal in the entire Northeast. Also Texas, New Mexico. And all that's going to happen is they're going to get hit again. Check it out. Let's play this through. More cold coming in on the October 22nd to the Northeast. Half the country is going to be in a 12 degrees below average. Let's move on. Look at solar ham. You can see no sunspots. Check out the map. Who's predicting today? Cook. It's actually yesterday. We've got a small incoming coronal hole here. Got some filaments in the center of the sun, and like I said, the northeast and south, the northwest and the southeast, we got filaments. No big deal there. Let's check out the NASA GOES water vapor map. What's bringing that cold air? Well, I'll tell you. Canada and the jet stream. Let's look at some more data. Head to spaceweather.com, because now we're going to start talking about cosmic rays. Spaceweather.com also tracks near-Earth objects, which is always interesting. There you go. There's their diagram of the inner solar system. But why are we scrolling down? Because of cosmic rays, which, by the way, have been increasing 18% for the past 5 years. Why is it relevant? Well, cosmic rays are ultra-high energy particles coming from space. Where do they come from? Well, they primarily come from local clusters. Things like Deneb, Cygnus X3. Now, most cosmic rays are hydrogen protons traveling nearly at the speed of light. When they smash into the Earth's atmosphere, now keep in mind they're highly charged, so most of these end up being charge separated at the poles. When they hit the atmosphere, they react with things. They cause secondary particle showers, as you see a diagram of here. This is an artist's rendition of what happens when an ultra-high energy particle hits the Earth's atmosphere. It branches out, it causes ionization paths, and it causes cloud nucleation, making the planet colder. We discovered cosmic rays in 1912. We've been studying them ever since. Now, we used to think air was an insulator and not an electric conductor. Obviously not true. Now, the article's telling us atom fragments such as protons, positively charged particles, also electrons. And then you've got, beyond that, you've got things like helium nuclei. We're measuring these all around the world. We're using balloons to measure them because we're very interested in what happens to people on planes and people in spacecraft. Anybody up above, say, 20,000 feet of altitude are getting a lot more cosmic rays than anybody on the ground. And the higher your latitude, the farther away from the equator you are, the more cosmic rays you will absorb. Do we have monitors? Well, we sure do have monitors. I'm going to leave the links below for these. Here's the University of Delaware. Has a big panel. We're not going to get into trying to analyze this data here. You'll have to immerse yourself in this for a while to understand it. And some of it's actually old. But here's the Oulu cosmic rays, which also has links to 2 different monitors in Antarctica. There you can see the historic. It was high at the last solar minimum around 2008, 2009. This data only goes up to 2017. Let's check Antarctica. Got your daily pressure corrected data, hourly averages. This one's pretty up to date. A different Antarctican site. So there you have that. Again, we're going to leave links below. Now, I'm going to do something we don't usually do, and that's go to Google Chrome. Talk for just a minute about our favorite cosmic ray source, Deneb, a star that you can see with the naked eye. We think it's about 3,000 light years away, but we're not exactly sure because of its behavior. Here's a great photograph of Deneb, which is part of the Summer Triangle, along with Vega and Altair. It's in the constellation Cygnus. It's the backside of the Swan. Now, this is one of the most distant stars you'll ever see with your eye alone because it's one of the Milky Way's most luminous stars. It's about 200 times the diameter of the Sun. It has a massive, what some astronomers refer to as a microquasar rotating around it at an insane speed. The reason we don't know the distance is because we use parallax to measure that. And it's very tough to measure the parallax because it's too far away. It's extremely bright. It's a blue-white supergiant. Again, about 200 times the diameter of the Sun. And to make things even crazier, this cosmic ray source becomes the celestial pole of our planet. Here's a rendition showing you how large Deneb is compared to the Sun. It also emits about 1,000 times more dense solar wind. Here's a constellation Cygnus. By the way, you can see where this is in the sky any time of day. If you're in the northern hemisphere, it rises and sets every day. Now, check out inthesky.org. Get yourself a great sky map. I'll show you how to operate this thing. So, right now, let's say you're in Chicago. There's the sky overhead. We like to have the ecliptic turned on. Shows us where the sun's going to go across the sky. Just look in a direction, rotate the wheel, and the sky will match what you're looking at. Now you can see right now in Chicago, Cygnus is right here. It's getting close to setting in the northwest, but it will rise again as it always does. And if you need to change your location, just come up here, click on the little wrench, type in the name of your town, which isn't going to display correctly. But that's how you do it. You can also animate the map, which will show you how the stars will set and so forth. And there you have it. We are expecting this KP of 0 to end at some point today, as again, some folks are predicting a geomagnetic storm today. Be safe out there. May the wind be at your back and the atherosclerosis absent from your arteries.